In this video, we'll look at how to lay out a common rafter using metric units. We'll look at the terminology of roof framing, how to work with the different ways that roof slopes are given on metric plans. We'll look at what the building code says about rafters, and then go over how to lay out a rafter using both the step-off method and by calculating the line length. Although most roofs in Canada today are framed with prefabricated trusses, knowing how to lay out and cut rafters will always be a fundamental skill for carpenters. Hand-cut rafters are often used in combination with trusses and on custom homes, porches, outbuildings, and renovations. Complex roofs can have intersecting valleys and hips, unequal or multiple slopes, and require an in-depth knowledge of geometry. But the simple gable roof that we'll look at in this video is framed up with just common rafters and requires understanding of just a few terms and techniques that we'll review here. The distance spanned by a pair of common rafters is called the span, and is measured to the building line, which is the plane of the outside of the wall framing, not including the sheathing. Half of the span is called the run of the rafter, and the run makes the bottom of what is known as the roof triangle. The center line of the building makes the vertical leg of the roof triangle, and its length is called the rise of the roof. The hypotenuse of the roof triangle is called the measuring line in roof framing, and its length is called the line length of the rafter. The roof triangle is the basis for calculating rafter lengths and angles, but it's important to note that the measuring line doesn't line up with either the top or the bottom edge of the rafter, and that the total rise of the roof triangle is not the same as the height of the roof framing. Cuts on common rafters generally consist only of plumb cuts, which are vertical, and level cuts, which are horizontal. The rafter is fitted to the top plate with a notch called the bird's mouth, which is made with a plumb cut and a level cut. The level cut of a bird's mouth is called the seat cut, and the part of the rafter directly above the seat cut is called the heel. The tail of the rafter extends past the bird's mouth, making the overhang of the roof. The tail generally has a plumb cut and sometimes a level cut. The plumb and level cuts of the tail provide a surface for attaching a vertical fascia board and a horizontal soffit to enclose the underside of the roof overhang. The plumb cut at the top of the rafter fits against the ridge board, and it needs to be adjusted by half of the thickness of the ridge board back from the center line. If sheathing is installed on the walls before the rafters, then the plumb cut of the bird's mouth also needs to be adjusted by the thickness of the sheathing back away from the building line. The height of the rafter that remains after the bird's mouth is cut is called by many names, including the height above plate, and it is measured along the building line. Adding that height above plate to the total rise of the roof triangle will give you the finished height of the roof framing. The horizontal distance that a rafter tail extends past the building line is called the projection, and its length along the slope of the rafter is called the overhang. The plans will show whether a fascia is included in this measurement, and if so, you'll need to deduct the thickness of the fascia from the length of the tail. Gable roof slopes can go from very low to very high and anywhere in between. The slope of the roof will usually be given on the plans using some variation of the slope triangle as shown here. Different parts of the world express the same slopes in different ways. Most countries use some variation of rise to run, but some places in the world also use degrees for roof slopes. We'll have a quick look here at how to interpret all the different systems used around the world to express roof slopes and how to move back and forth between them. In North America, we see percentages used to express the steepness of roads and ski hills, but around the rest of the world, it's the most common way to express roof slopes. It's a rise over run system where the run is always 100. One thing to keep in mind if you're new to percentages is that 100% slope, or 100 units of rise to 100 units of run, is a 45-degree angle, not a vertical line. This metric rafter layout square has a scale for marking plumb cuts on rafters from 10% up to 300% slopes. Pivoting the corner of the square around the edge of your lumber and lining up the number 2 in the common rafter scale will give you a plumb cut for a 20% slope. Percent slopes are interchangeable with the decimal slopes used in some countries, including Japan, which use units of rise per 10 units of run. Aligning the number 30 on this rafter square will give a plumb cut for a rafter with a 30 to 10 slope, which is the same as 300%. The Canadian Building Code uses a rise-to-run ratio called gradients to express roof slope. And if you see some odd numbers in there, it's because these are direct equivalents of the feet and inches system used throughout North America. In contrast to the other rise and run systems in the world, these gradients use a constant rise and a variable run. Here's how it works.
1 to 1 has both a rise and run of 1, making it equivalent to 12-12, 100%, 10 to 10, or 45 degrees. 1 to 2 has a rise of 1 and a run of 2, making it equivalent to 6-12, 50%, 5 to 10, or around 26 degrees. 1 to 4 is the same as 3 to 12, 25%, 2.5 to 10, or around 14 degrees.
Of the many different ways that are used to express roof slopes, the tangent ratio is definitely the most useful of all of them. But it's one that very few carpenters use. Put simply, a tangent is the rise of a slope per single unit of run. The name tangent comes from the trigonometry developed by ancient astronomers, and tangents have long been used for surveying and navigation. For carpenters, the tangent ratio is the single most useful way to express rise and run, because the tangent, multiplied by any run, in any units, is equal to the rise for that run. The good news is that any rise and run system can be quickly reduced to the tangent ratio just by dividing the rise by the run. Whether your slope is given in gradients, percent, decimals, or rise over 12 inches, just divide the rise by the run and you'll have the tangent. In the UK and Scandinavia, construction plans use degrees to specify roof slopes. This simplifies angle cutting with miter saws and marking with speed squares, but it complicates using the step-off method or calculating a line length. British carpenters use this reference book to convert degrees to rise and run and to find line lengths. But with a couple of keys on a pocket calculator, you can quickly find all the information you need. The tan key will convert degrees to the tangent ratio, which is rise per single unit of run. And the arctangent, or tan to the -1 key, will convert any tangent to degrees. Here's a couple of examples. Say your plans indicate a roof slope of 35 degrees. Punch 35 into your calculator and hit the tan key. You'll get a result of 0.7. That means that if the run is 1 of any unit, the rise is 0.7 of those units. Multiples of this tangent give us 7 to 10, or 70%. Here's a 42-degree slope. Put 42 into the calculator, hit tan, and you get 0.9, which is 0.9 units of rise per single unit of run. In other words, it's a slope of 9 to 10, or 90%. Now, if your slope is given in rise over run, but you want to get it into degrees, use that tan to the -1 or arctangent key. For a 50% slope, divide 50 by 100 to get a tangent of 0.5. Hit the arctangent key and it shows 26.5 degrees. For a 1 to 1.5 slope, divide 1 by 1.5 to get a tangent of 0.6 repeating. Hit the arctangent key and it shows an angle of 33.7 degrees. For a 12-12 slope, divide 12 by 12 to get a tangent of 1. Hit the arctangent key and it shows an angle of 45 degrees. Building codes around the world specify safe parameters for rafter construction. Here's a few examples from Canada. First, sizing a rafter starts with the span tables. Span tables specify the minimum dimension of a rafter for a given span, spacing, snow load, and wood species. Next, notch depths are typically limited to 1/3 of the depth of the rafter, unless oversized rafters are being used to accommodate a deeper notch. An overcut bird's mouth weakens the rafter tail, which could cause it to fail under load. Third, the heel of the rafter needs to have a minimum of 38 millimeters of bearing on the top plate. The seat cut can extend to the inner edge of the top plate, but should never be overcut, leaving the heel unsupported, because the rafter will be weakened and could fail under load. The fastest and easiest way of laying out a short common rafter is by using a carpenter's framing square and the step-off method. In the step-off method, the framing square is set up with either stair gauges or a fence set to any convenient multiple of the rise and run of the roof slope. Then, the run of the rafter is measured horizontally from ridge to building line. In this example, we'll use a rafter cut to a 1-to-2 slope and a 500 millimeter run. The first step is to find a multiple of that 1-to-2 slope that conveniently fits on one of our 400 by 600 framing squares. Multiples include 150 to 300, 200 to 400, or 250 to 500. All of these would fit the bill. We'll use the 150 to 300 for this example. This is a framing square with a fence that takes about 3 minutes to make out of an offcut and a few screws. If you've been using stair gauges, make yourself one of these. You'll never go back. Before turning a piece of lumber into a rafter, sight along the edge and look for an edgeways bow or crown in the board. Rafters and floor joists should be installed with the crown facing up so that their weight tends to straighten them as they sag. Start the layout by marking the center line of the ridge. Then, without moving the square, measure off the horizontal run of the rafter. In this example, the run is 500 millimeters, so I'm counting off 300 millimeters, making a mark, stepping the square along until the 0 aligns with that 300 millimeter mark, and then counting off another 200 millimeters for a total of 500. This is the location of the building line, which I'll mark with the plumb line. The plans show a projection of 150 millimeters past the building line, including a 38 by 89 rough fascia. To mark that, slide any convenient measurement to the building line. I'm using the 0 in this example. And then measure 150 millimeters past the building line and put a tick mark. A plumb line here shows the outside face of the rough fascia. Next, we'll figure out the height above plate and mark the seat cut of the bird's mouth. If you're using wider rafter stock, you'll probably make the seat cut equal to the width of the top plate. On this narrow rafter, we'll measure the height of the building line, divide by 3, and mark 1/3 of the total for the height of the seat cut. Round that down if you'll be extending the bird's mouth notch over the sheathing. Now we'll make the adjustment at the ridge. The 19 millimeter adjustment for half the thickness of the ridge needs to be measured horizontally, not along the slope of the rafter. To do that, slide your framing square fence along until any convenient measurement on the run of the square aligns with the center line. Measure 19 millimeters, put a tick mark, and then mark the plumb cut line for your ridge. Now let's do the adjustment for the sheathing. On these plans, the sheathing is 12 millimeters thick. and that's going to be on the outside of the building line. Slide the square along so that any convenient measurement aligns with the building line. Measure over 12 millimeters along the horizontal and put a tick mark. Put your pencil on the tick mark, slide your square down to it, strike your line. And that's the plumb cut line of your bird's mouth. Finally, we'll do the adjustment for the rough fascia. For this rafter, we need to deduct the 38 millimeter thickness of the rough fascia from the 150 millimeter projection of the rafter tail. With the framing square, measure back 38 millimeters along the horizontal and make a tick mark. Remember, never measure these adjustments along the slope of the rafter. Always measure perpendicular to your plumb lines. Strike a plumb line through your tick mark and you have the plumb cut line of your rafter tail. There's your layout, all done. To test your layout, cut 2 rafters and stand them up on your wall plates with a piece of 2x in between them to represent the ridge. If they're good, use one of them as a pattern and trace the rest. The step-off method is ideal for occasional use on short rafters, but it's prone to compound error, so it's not ideal for precise work on longer rafters. Also, you can't do the step-off method with the speed square. So, bring your rafter layout skills to the next level by learning how to calculate the line length. Remember earlier in the video I said that the tangent ratio is the most useful way to express roof slopes? Now you'll see why. The tangent ratio is the rise per single unit of run, and there's also a ratio for the length of a rafter per single unit of run. A lot of carpenters call this ratio just that, the line length per unit of run. But it's got other names as well. In trigonometry, it's called the secant ratio. Alberta carpenters call it the slope gain factor, or the SGF, and the span tables call it the slope factor. What's good about the secant ratio is that you can multiply it by any run in any units, and it will give you the line length in those units. Here's how to find the secant for any roof slope. First, find the tangent of your roof slope by dividing the rise by the run. Or if your slope is in degrees, just use the tan key. Then, do Pythagoras' theorem with that unit triangle. Just square the tangent using the x squared key, then add 1 squared, which is just 1. Find the square root of that number, and that's the length of the hypotenuse of your unit triangle, which is also your secant ratio for that roof slope. You'll find this ratio in pre-calculated tables in the span book, but once you know how, it's very simple to find it for yourself for any roof slope with just an inexpensive pocket calculator. If you're using a framing square for laying out your rafter, you may find that it's fastest to calculate the overall line length, mark that on your rafter stock, and then measure and mark your adjustments exactly like you do in the step-off method. I recommend drawing a diagram or drawing right on your plans to record every significant number as you go. The overall line length goes from the center line to the building line, so prepare extension and dimension lines to be ready for that number. In this example, we'll also get the line length of the overhang. The run of the projection is already on the plans, and we'll add in the run of the rafter by dividing the span in half. Now, to get the line length of the rafter, multiply the run by the secant. It's that easy, and it's dead accurate. Do the same for the run of the projection. When calculating the tangent and the secant, Avoid rounding your numbers to ensure that your final result is accurate. But once you have your final measurement, round that to the nearest millimeter, because that's as close as you can actually measure on your tape. While we're doing calculations, we'll get the total of these two line lengths onto the drawing as well, so that we can avoid compound error by measuring both points from the same reference point. Now to lay out the rafter. For this one, we'll use stair gauges. Our 1 to 1.5 slope equates to 2 to 3, which also equates to 200 to 300. The stair gauges can go on either edge of the square. Just make sure that for your measurements, you're aligning the outside edges of the square. The first line to draw is the center line of the ridge. Align your center line with the corner of the board so that a tape hooked on the end of the board will give a precise measurement. Measure along the top edge of the lumber and mark your measurements for the building line and the plumb line of the projection. Carefully mark these plumb lines with your framing square. It helps to label them as you go. Next, shorten the rafter by half the thickness of the ridge board. Measure horizontally from the center line and mark the plumb cut for the ridge. These plans show a rough fascia included in the projection measurement, so we'll shorten the tail of the rafter by the thickness of the rough fascia. For the seat cut, make sure that the bird's mouth ends up no more than 1/3 of the width of the rafter, and that the seat cut is no longer than the width of the top plate. Again, if sheathing is applied before the rafters are cut, extend the bird's mouth plumb cut to allow for the thickness of the sheathing. Mark your bird's mouth cut lines long to make them easier to follow with your circular saw. There's the rafter ready to cut out. Clamp small rafters down for cutting so that you can keep both hands on the circular saw. For small rafters like this one, it's much easier to make all your cuts while the rafter is still attached to the end of a longer board, so that your clamps aren't in the way of your saw. Set your saw depth so that only 6 millimeters or 1 sawtooth extends below the board you're cutting. Finish bird's mouth cuts with a handsaw rather than weakening the rafter by overcutting with your circular saw. Your last cut will separate the rafter from the rest of the board after all your other cuts are done. If you're using a speed square for your layout instead of a framing square, you won't be able to step off your adjustments as quickly and accurately. So I recommend calculating all of your adjustments on your plans so that you can go straight to marking the cut lines on your rafter stock. In this example, we have to calculate the runs between the face of the ridge board, the outside face of the sheathing, and the inside face of the rough fascia in order to get the line lengths between the cut lines. To our 500 millimeter run, we'll need to add 12 millimeters for the sheathing and subtract 19 millimeters for half of the thickness of the ridge. This leaves a run of 493 millimeters between the ridge plumb cut and the bird's mouth plumb cut. From the 150 millimeter run of the projection, we need to subtract the thickness of the sheathing and the 38 millimeter thickness of the rough fascia to get the adjusted run between the bird's mouth plumb cut and the tail plumb cut. Now we'll find the secant for our 1 to 2 roof slope. Divide the rise by the run to get the tangent. Square the tangent, add 1, and then use square root of x to find the secant. Our 1 to 2 slope is the same as 50%, 6 to 12, and quarter pitch. Here's the secant for it in these tables. Now multiply the 2 runs by the secant to get the line lengths that you're going to mark on your rafter stock. To avoid compound error, you will want to pull all your measurements from the tip of the ridge plumb cut. So also put in the running total on your diagram. Now let's lay out this rafter. A tangent of 0.5 equates to the 50% or 5 mark on your metric speed square. After sighting your stock for crown, mark the plumb cut of the ridge right at the top corner of the rafter so that you can hook a tape on the end and pull all of your measurements from that single point. Then, mark your adjusted line lengths right on the top corner of the rafter stock. If you don't mark them on the top corner, your lines will not be in the correct locations. From your tick marks, use your speed square to mark these plumb cuts for a 5 to 10 slope. Then, measure for the appropriate height of your seat cut and use your square to draw your seat cut 90 degrees to the plumb cut line. Cut out your rafter and check it for fit before making the rest. And that wraps up this video. Now, no matter what slope is given to you or what format it's given in, you can calculate its tangent and secant and quickly lay out an accurate rafter.